Hey everybody, today I'm going to define what a positive exponent is and show you with lots of examples how you can simplify expressions that contain exponents. First of all, a positive exponent simply means repeated multiplication. It's like a code. If you notice here you see x raised to the fourth power. What that little 4 means is that x has to be multiplied by x 4 different times. So x times x times x times x. We have names for each of these things. X is called the base, and that little 4 is called the exponent. Now when we say it as I did, x to the fourth power, or in this example, x to the third power. Now that one has a special name. We sometimes call that x cubed. And x to the second power has a special name as well. We often call that x squared. For the rest of them, anything to any other power above 4, there's no special names. You just say to the nth power. Now, when you're working with exponents, there's one rule that I think applies more than there's one rule that's more important than any others, and so I call it the number one rule of exponents. That is that the exponent only applies to either the number or variable or at times a whole group that is directly before it. It does not apply to anything else on either side of it, way before it, or immediately afterward. So as a few examples, in this example, 3 times x to the fourth, this 4 only applies to the x. And so this expression in what we call expanded form is 3, just once, times x times x times x times x. If you wanted the 3 repeated as well, then you would put the 3 and the x in parentheses like this. Then that means that whole group is repeated 4 times, and so you'd have 3x times 3x times 3x times 3x. And since multiplication is commutative, we could rearrange that and have 3 times 3 times 3 times 3 times x times x times x times x. And we can even group that together and write it as 3 to the fourth power times x to the fourth power. Now the time when this gets most tricky is when there's a negative involved. Negative m to the fourth power, that 4 applies only to the m. And so that simplified, so that expanded gives us negative m times m times m times m. If you want that negative also to be multiplied 4 times, you put it in parentheses. That gives us negative m times negative m times negative m times negative m. And since there are 4 negatives and they cancel themselves out in pairs, that expression simplifies to positive m to the fourth. Now, I mentioned earlier the word simplified. When we're working with exponents, there's a way of writing things that's called simplified form. That is having no unnecessary negatives. So in that last example when you saw negative, 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 m, those 4 negatives we would deal with and get rid of. Another part of simplified form is that any numbers involved, any number factors that is, need to be multiplied out. So instead of writing 3 to the fourth power, I should have done 3 times 3 is 9, times 3 is 27, times 3 is 81, and wrote that. Finally, any variable factors should be sorted, rearranged, and gathered together. So let's look at a few examples of simplified form. In this example, 3ab squared times a to the fourth times b to the second power. The first thing I would do is look at this 3ab squared. That means 3 times a times b, and then again 3 times a times b, because that 2 applies to this entire group. A to the fourth power means a times a times a times a, and b to the second power, that 2 only applies to this b, so I'll write that twice, b times b. And each of these factors, there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors in whole. Each of those factors can be rearranged. And what I usually do is I bring the numbers together in front, so 3 times 3. And then I've got 1, 2, 3, 4, 5, 6 A's. And 1, 2, 3, 4 B's. And now we'll walk through the rules of simplified form. First of all, there should be no unnecessary negatives. That's not a problem here because there's no negatives at all. Second of all, any numbers, which I've moved to be in front here, need to be multiplied out. That's easy enough. 3 times 3 is 9. And finally, any variable factors should be sorted and gathered together. Here, there are 6 total factors of A. Rather than writing A out 6 times, which makes it hard to count and maybe see immediately, we would write this as A to the 6th power. And then for the B's, there are 4, and so we would write B to the 4th power. This here would be our final answer if they asked us to simplify the expression. Now, admittedly, this is a little time-consuming to write up all these different factors, and you don't need to do that all the time. A lot of people can do this sort of thing in their head, or parts of this in their head. Or, in the next couple of videos, you'll learn some properties that we can use that will help us get from this expression to our simplified answer a little more quickly. But I wanted to show you this because you can always resort to writing it out. And in fact, I often do. When in doubt, I'll write it out, and that will show me what I've got, and then I can simplify it a little bit more easily. In our next example, this is a little bit more complicated, about as hard as you might see in your homework. I've got one expression that's raised to the 3rd power, and another expression that's raised to the 2nd power, and then that whole thing is in the square brackets. That's raised to the 2nd power. If I wanted to write out what this literally means with all those exponents, I would probably start here. Negative 4x squared y means negative 4. The x squared means x times x. Notice that that 2 only applies to the x, and then a y. And that is this group, and that whole group needs to be written out 3 times. So, again, I multiply by a negative 4xxy, and then again by a negative 4xxy. Now I'm being a little lazy here because I'm not writing in all the multiplication signs. Really, these are all multiplications, and so this is really a negative 4 and not minus 4x squared y. We'll get into mixtures of adding and subtracting later on when we talk about polynomials, but for this particular unit, everything that we do needs to be multiplied or maybe divided together. This next group, xy with the squared by it, means the x and the y are being written out together twice. So xy, xy. And that is this whole group. And that whole group is still squared. We haven't dealt with that squared yet. That would mean, if I wrote this out in its entirety, I would have to write this whole thing again. So, rather than writing out that whole thing again, let's see if we can think through what that might look like. If I did that, there would be another negative 4xxy, and another negative 4xxy, and a 6th negative 4xxy. And then at the end of that chain, there would be another xy, xy. As we move to simplify this expression, let's practice this sorting out and thinking about each of these things individually. First of all, I need to deal with the negatives. I need to make sure that there are no unnecessary negatives. there is 1 negative factor, 2 negative factors, 3 negative factors, plus, remember, there were 3 more negatives in the repeated group on the side. That makes a total of 6 negative factors. And remember that negative times negative is a positive. Negative times negative is a positive. And negative times negative is a positive. So, as a whole, all of those negative signs cancel themselves out, and my answer ends up being positive. To indicate that, you could write a positive, but we usually just don't write any negative, and that means positive. Next, I'll look at all the numbers. I've got 4 times 4 times 4, and then there was 4 times 4 times 4. I could write that as 4 to the 6th, but the rule for numbers is that number factors should be actually multiplied out. So 4 times 4 is 16, times 4 is 64, and at this point I kind of get overwhelmed. So let's use a calculator. To type in a power like this on a TI-83 or 84, you'll have to press 4, and then this little symbol here is the power button. So you press that, and then raise it to the 6th power. 4 raised to the 6th power. Notice that's the exact same thing as if I had typed 4 times 4 times 4 times 4 times 4 times 4. For this particular problem, it might have been just as easy to do that, but we're eventually going to get to some where the powers are really high, and so I want you to know where that exponent button is. So, back to our problem, we would write then 4096. The next thing would be to figure out how many total x's there are. Here's an x times 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 x. That's a total of 1, 2, 3, 4, 5, 6, 7, 8 factors of x in the first group. And there must also be 8 factors of x in that second group. That's a total of 16 factors of x if we were to rearrange them all. And so we would write x raised to the 16th power. Finally, there's 1, 2, 3, 4, 5 factors of y in one of these groups. And if we look in the second group, there's 5 factors of y in that group as well. That gives us a total of 10 factors of y. So our final answer is 4096 x to the 16th, y to the 10th. That's what this original expression is equal to. Now, with an expression that's this complicated, it'd be nice to be able to check our work and see if our simplification is done correctly. On a calculator, we can do this. Unfortunately, the calculator doesn't just give us our answer, but we can type in what we had originally and type in our answer, and if those things really are equivalent, then we should get the same number for those. So to type in our original statement, the calculator requires you to always use curved parentheses. I do know that there are square brackets available above the times and minus the, but those are designed for matrix use, and you can't use them just in general everyday calculations. The only thing we can use is the parentheses. So I'll start off by using 2 open parentheses, and then the negative button, and 4, and then alpha x. The squared button is here, and then alpha y. Then our first close parenthesis, and you could type in the cubed button, which is in the math menu, or you could also type raised to the 3rd power. Either of those works. Then another open parenthesis, and alpha x, alpha y, and a closed parenthesis, and the squared, and then another closed parenthesis, which is the square brace at the end, and then a squared. And when I hit enter, this gives me a 0. Now when I type in my final answer, 4,096 times x raised to the 16th power, notice how I use this parenthesis, times y raised to the 10th power. I should also get a 0, or else I made a calculation error. Since I got the same thing both times, I'm pretty confident that these two expressions are the same. Now, if you did this on your own calculator, I wouldn't be surprised if you got something besides zeros. The fact that I got a 0 doesn't matter. The most important part is that those numbers matched. So if you typed it in originally and then you typed in the final answer and you got the same number, whatever it was, both times, then you can know that those two expressions are equal.